Okay, for this question, the first thing I would do is just get the volume of a cylinder, right? So they're talking about cylinders. Anytime they're talking about cylinders, get that formula. And remember, they give you a bunch of geometry formulas at the beginning of every math section. Flip back, and you'll see that the cylinder formula is among them. Volume is equal to pi r squared h. So this is just a good example of get back to basics, put it down there, and start from there. So now what do they tell us? The volume of right circular cylinder A is 22 cubic centimeters. Okay, so I might do something like this. 22 is equal to pi r squared h. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? So what a lot of people do here is then they create something about cylinder B, and okay, we want the volume and pi r squared, so twice the radius and half the height. So we can just twice the radius and half the height. Let's do that. 1/2 h. So they do something like this, and they kind of take what's being said in the problem and then they just turn it into some sort of algebra expression. The problem is here I've made a mistake, and it's hard to notice, and a lot of people make this mistake. Really what I need to make sure that I do here is when I plug something in for r, the whole radius in the formula is squared. So it's going to look like that, 2r squared. Okay? Before I continue with this, I want to show you a safer way to do it. We could continue with the algebra, I fixed the problem, but the point is with algebra, we often don't know when we've made the mistake because it's algebra and it's not something that our brain understands intuitively. So there's equations, there's a lot of stuff that has to be right at once. And so we're not likely to notice when something is wrong because we just don't think in algebraic terms. What we do think of, especially with geometry, is in numeric terms, right? I mean, cylinders have shapes, they have dimensions, they have actual things that we can, with a ruler, measure in normal life. So that would be the better way to do things. And that would mean that we're going to need to arithmetize here because we don't actually have any of these dimensions. I know that we need twice the radius and half the height, and 22 is kind of a messy number. So I'm going to do some things here with arithmetizing that are maybe a little weird. So what I would do is focus on cylinder A, and I would pick some very convenient numbers. So what I would pick is that my radius is 1 and my height is 22. So why is that going to be good? Well, it's going to let me divide 22 in half very easily to get 11, right? Because we're supposed to divide the height in half. And it's going to let me double the radius easily because 1 times 2 is just 2. So the numbers work out nicely because I can change them in the way that I want to change them very easily. And because number 22 is not really like a convenient number, there's not a lot of ways to break it apart, I'm kind of limited in what I can do. And so this kind of is the best of all possible worlds. However, I did something that isn't really mathematically okay, because what I wrote here is not true. 22 times 1 squared times pi is not equal to 22, right? It's equal to 22 pi, and pi is a number, 3.14, blah, blah, blah. So technically, I do not have a true equation here. And there are things I can do to make it true. I could make the height not 22. I could make it 22 over pi. And that way the pi's would cancel. But that's confusing for most people, so I'm going to avoid that. And I'm going to do just something a little different. I'm just going to make it clear from the start that pi is irrelevant. Because think about what this formula is, right? It's 2 variables, the radius and the height, and those things are changing. But pi, even though it looks kind of like a variable because it's a symbol, is a number. And it's a number that doesn't change. Pi has a specific value. So I'm kind of using that to my advantage here. I know that certain aspects of the cylinder are going to change, or that certain aspects of the formula are going to change, but I know that pi is a constant. So I'm kind of cheating a little bit, and just because I'm comfortable with math, I know that I can just ignore all the pi's and just pretend that they don't even exist from the start, and then choose numbers to understand the change and not worry about the things that don't change. So, is it cheating? A little bit. But confidence in math and understanding the difference between a constant and a variable, that's what allows me to make that little substitution and not worry about it so much. Because now I can focus on the things that do change, and especially that's going to affect the volume, and I can see how that change is going to play out, right? Because I was told that I need twice the radius. So twice 1 is going to be 2, right? So I'm going to put pi r squared, so that's 2 squared, and half the height is going to be half of 22, which is 11. So to get from here to here, I applied the rules that I was told. I'm just following instructions, but now those instructions are easier because I don't have to worry about variables. I can just use numbers, right? Doubling 1 is 2, and half of 22 is 11. And so now it's just a simple math problem, right? The volume is equal to, in this case, 2 squared is 4. So 4 times 11 is 44, and that's the answer. So there you go. And that works. This is arithmetizing. It's the kind of arithmetizing that you would only get more comfortable with as you practice arithmetizing, because it really does require confidence with that strategy. It's not something you're going to get, just out of the box. So this is an element that takes practice. But this is why I love the arithmetize strategy, is once you are comfortable with it, it's really powerful and can help you understand things and avoid mistakes in very interesting situations. Now, if I didn't do that, I would need to do more of what I started out with. So let me rewrite this. Remember, we have two things. We have the volume of A, which is pi r squared h, and the volume of B, which is going to be pi r squared h. But remember, we're doing twice the radius and half the height. And because they told us the volume of A is equal to 22, I can make that substitution. But the next piece of substitution is not going to be as obvious for most people. So what do? Well, first let's clean up volume of B. Let's do some algebra here. So 2r, the quantity squared, is 4r squared. And that's going to allow me to do 4r squared, or 4 pi. Can't forget the pi. I'm not cutting it out in this situation. 4 pi r squared h over 2. And so I can even reduce that further to get 2 pi r squared h. And here's where we use a skill that actually does come up on the SAT fairly often. It's where instead of our normal habit of solving for every variable and getting an r equals and an h equals, we instead treat groups of numbers and variables as a unit, and we solve for the unit. So the unit right here has already been solved for us on the left, pi r squared h. And we have that same unit on the right, pi r squared h. So I can do substitution. And it's going to be a weird kind of substitution that in math class in school you don't do very often, but I'm going to substitute pi r squared h as a unit here. And I know that pi r squared h is equal to 22, so I can make that substitution. And suddenly I get that the volume of B is equal to 2 times the 22, where, just to be clear, the 22 is what this unit represents. And there you go. That is equal to 44. Same answer that we got when we plugged in and used arithmetize. This is a tricky question. I think that no matter what way you solve it, whether you use the arithmetize strategy or just stick to the algebra, there's a lot of potential for error. There are a lot of things that you kind of need to be aware of and thinking about, and that might not be easy on what's just a question 11. This is supposed to be a hard question, but yeah, I don't know. I mean, it seems a little hard for the first hard question. I would say, though, that the big trap answer here is B, right? And you might actually get that if you make the algebra mistake. So you might actually feel pretty good about that answer because of the proof that you have with your algebra that's bad. But I think also just reading the question, that's the answer that a lot of people are drawn to, because you'd think, well, if I'm taking twice the radius and half the height, that cancels out, right? Doubling the radius, halving the height, those should cancel, double, half, and so we get back to where we started, which was 22. And so if you picked choice B without doing any work at all, you fell for a classic SAT mistake. You picked an easy answer to a question that's supposed to be hard. You're not going to be able to get these things with instinct. You're going to need to get them with proof. And you need, hopefully, you have different ways of proving it, whether it's with real numbers or with just reliable algebra. But this is going to be more than a 2-second question no matter what you do. So if you get your answer in 2 seconds, that should be a signal that you probably did something wrong.